Machholz, and you are listening to Looking Up with Don. This is the Looking Up with Don podcast, episode number 11 for the week of March 18th, 2020. The related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com, 2 H's. So, what's up in the sky this week? As our week begins on Wednesday, March 18th, the moon is about 30% full in the morning sky, almost a crescent, and headed towards new moon on March 24th. With very little moon in the sky this week and next week, it's a good time to get out and do the Messier Marathon. For the next 2 weeks from mid-northern latitudes, all the Messier objects should be visible except for M30. On Wednesday, March 18th, the moon passes in front of Mars, seen from the southern hemisphere in the Pacific Ocean area. The moon passes south of Jupiter also on March 18th. Jupiter hangs in our southwestern sky. This week it reaches its greatest elongation, 46 degrees. The elongation is the angular distance in degrees in this case from the Sun to the object seen from the Earth. Venus appears 46 degrees from the Sun on March 24th. It is high in our evening sky as darkness falls over our western sky. Our morning sky has the planets Mars, Jupiter, and Saturn, plus the moon this week. As mentioned earlier, on March 18th, the crescent moon passes both Mars and Jupiter. Less than a day later, it passes south of the planet Saturn. A good combination of the moon, Mars, Jupiter, and to some extent Saturn will be visible in our morning sky, and this makes for a good photo opportunity, or at least some viewing with the unaided eye or binoculars. This is one of the best planetary and moon alignments of the year, March 18th through the 20th. On March 20th, Mars passes less than a degree south of Jupiter. Both are traveling eastward at this time, but Mars is much faster and it overtakes Jupiter. Jupiter is 3 magnitudes brighter than Mars. That is, it's 16 times brighter. Jupiter is 3.5 times farther away from us than is Mars, but it is larger and it reflects more light. 2 days later, March 22nd, 23rd, Mars passes within 2 arc minutes of the object formerly known as the planet Pluto. It's still called Pluto, it's just not classified as a planet. You would need a telescope to see it, and even then it would be nearly impossible to see Pluto with the bright planet Mars right next to it. Imaging it might be the only way this close approach can be noted. Also on March 24th, the same day as the new moon, and the same day that the planet Venus reaches greatest elongation in the evening sky, the planet Mercury reaches greatest elongation in the morning sky, 28 degrees from the Sun. This might be more important astrologically than astronomically. I don't know, as I do not study astrology. Anyway, Mercury will be better seen in the morning sky from the southern hemisphere than from the northern hemisphere on the few days centered on March 24th. The International Space Station is visible depending upon your location. Even though the International Space Station orbits the Earth every 90 minutes or so, when it passes over your head one point and then 90 minutes later it will not be over your head again, because the Earth has rotated underneath it, so it would be seen somewhere else. For this week, north of about 40 degrees north latitude, That would be England, Canada, Russia. You will get 1 and perhaps 2 International Space Station passes each evening. Between about the equator and 40 degrees north latitude, you'll have some evening passes until this weekend, then none at all. For most of the southern hemisphere, you'll see it in your morning sky. To find out when and where to see it, go to the website heavens-above.com, enter your location, and get finder's data. Now, the International Space Station is occasionally visited by other spacecraft bringing supplies or taking astronauts to and from the International Space Station. During those times, you might not only see the International Space Station going across the sky, but one of these other spacecraft following it or preceding it as they go across the sky together. Let's talk for a few minutes about one of the largest and one of the smallest things you can see in your sky, the zodiacal light. This is the effect of sunlight reflecting off of very tiny particles in our solar system. Each individual particle is small, but together they make up a large but dim cone of light in our western sky after sunset and our morning sky before sunrise. This cone is in the shape of a triangle, with a base at your horizon, and the triangle tapers off as we get higher in the sky. You have probably seen this before, but not recognized it. This time of the year is a good time to look for it, as it stands nearly straight up in the sky. In the northern hemisphere, it's in the western sky as the sky gets dark each evening. And in the southern hemisphere, it's in your morning sky just before dawn begins to brighten the sky. So let's look for it. This is how to see it. Get out there and get accustomed to the darkness. Begin looking about 90 minutes after sunset if you live in the northern hemisphere, and 90 minutes before sunrise if you live in the southern hemisphere. The sky is not of uniform darkness, but you should be able to pick out a glow that is about 10 to 20 degrees wide at the horizon and heads up the sky, tapering off the higher you get in the sky. The light is along our ecliptic, a slightly curved line on Map 1, Podcast 11, and this is where you'll find the major planets and the moon. So in the evening sky, the zodiacal light will head up toward the planet Venus, and in the morning sky, the zodiacal light will encompass the planets Saturn, Mars, and Jupiter. It is believed that the dust in the zodiacal light is from comets. So you're looking at comet material that's lost in space and orbiting the sun. The spring equinox is on March 19th, 20th, depending upon your time zone. Thanks in part to Leap Day this year, we have shoved an extra day into the calendar, and the spring equinox is a day earlier than usual. So what happens on the spring equinox? Can you really balance an egg on the end? Not really. But the sun does cross the equator headed north. With the sun on the equator on that day, all places on Earth get, theoretically, 12 hours of sun, although high horizons in your east or west may reduce that time. The sun will rise due east and set due west. So if you want to get a fix on your east and west points, that's the date to mark your sunrise and sunset points. In the northern hemisphere, after the sun rises, it heads up and to the right. As it sets, it moves down and to the right. In the southern hemisphere, it rises up and to the left and sets down and to the left. Remember that when you see a TV show or movie and they show a time-lapse sunrise or sunset. Sometimes you will notice they're actually running a sunrise video backwards, showing the sun setting or vice versa. Remember, if the sun sets as seen from the northern hemisphere, and it moves in the time-lapse frame from the right to the left as it descends, They are merely reversing a sunrise video and they have it all wrong. It should set from the left to the right. Conversely, and this happens more frequently, if they're trying to show a morning sunrise from the northern hemisphere and the sun rises and heads to the left, then they were merely using a sunset video and running it backwards. When I see that, I realize they don't know they're doing it wrong or they don't care, and they were too lazy to get up at sunrise to record it properly. As seen from the southern hemisphere, as I said, the reverse directions occur. But we are regressing, as we tend to do sometimes. From the spring equinox, March 19th, 20, to the autumn equinox, September 22nd, the sun will be north of the equator. Northern hemisphere will have more sun than darkness. And if you go really far north, Canada, England, Russia, in June and July, the sky doesn't get dark until more than 2 hours after sunset. Nights become really short. And at the North Pole, the sun is up 24/7. Good for solar astronomy. In the southern hemisphere, there's more darkness and sunlight. Nights are longer and colder. Get out those electric socks. Let's talk for a few minutes about public star parties. In the 1960s and 1970s, some of us heard about the San Francisco sidewalk astronomers. They would set up telescopes on street corners in San Francisco and show people the moon and planets. This is something you could do too if you have a telescope or even a pair of binoculars on a tripod. In fact, with simply a laser pointer, you could point out the constellation and planets to people. In 2 weeks, we will discuss school star parties and private star parties. This week and next week, it will be public star parties. A public star party is an event where local amateur astronomers set up telescopes to show astronomical objects to the public. A public star party often has 1, someone to direct it, 2, those who bring the telescopes, they are known as the host, and 3, the public who comes out to look through the telescope, and those are referred to as the guest. Not every amateur astronomer is willing and able to mix with the public this way, and I get it. You're not a bad person if you don't want to haul your telescope around the community for strangers. Again, I fully understand that. And I know a lot of amateur astronomers who've never done public star parties. They're extremely happy in what they do with astronomy. And they may never do a public star party, and that's great. They enjoy doing what they're doing. But some of you do want to do public star parties, and so I'm talking to you. The first public star party I directed was a series of 6 of them in 1985 and 1986 to view Halley's Comet in San Jose, California. Local astronomers, mostly from the San Jose Astronomical Association, all 17 of them, met in my living room to receive a packet and discuss the star parties. Inside the packet were maps showing where the comet would be on each of the 6 nights, directions to the park from where we would do the star parties, and facts about the comet. And from each of them, I learned what instrument each was bringing and which night they could be present. It is very important that the host, those with the telescopes, know a thing or two about the objects they show. In fact, the hosts have 2 jobs: to stay with their telescope, keeping the object centered in the eyepiece, and to explain to the guest what they are seeing. You never, ever want to have a telescope sitting there pointed at nothing. This frustrates the guests who walk over and look through. After I moved to the Colfax, California area in 1990, I began public star parties in the foothills and the Sierras of Northern California. At times, it was just me in 3 telescopes and as many as 40 guests. Each telescope was on a different object, and I announced every object as I found it to the whole group, such as, in this telescope we have the Ring Nebula. It's a planetary nebula, and it's 1,500 light years away or whatever. Now that took a loud voice, and I scrambled among the telescopes to make sure the object stayed centered. In time, other people joined me, other astronomers, and for the next 24 years, it was the main core of 4 of us with about 5 or 6 telescopes between us. We ran about 8 to 12 public star parties each year. Not all star parties are the same. We made sure that we were there for lunar eclipses, solar eclipses, transits of Mercury, bright comets, oppositions of Mars, and other notable events that were newsworthy. The Mars watches were some of our most popular. One year we had 17 telescopes set up on Mars, and about 300 people came out to see it. We even had someone directing traffic in the parking lot. Our star parties generally run for 90 minutes. That seemed to be the ideal time. Too long and the hosts get tired. Too short and you limit the number of guests that can show up during your observing window. We found that our guests would be there for anything from 10 minutes through the whole 90 minutes, with the average being about 30 minutes. We found that people came to our star parties, looked through a few telescopes, saw what they wanted to see, and quite often would just go home then. That's fine. They enjoyed themselves with a short investment of time. Others would hang out all 90 minutes, talking to the astronomers, continually looking through the telescopes. Often families would show up, and sometimes one of the local high schools would give their students extra credit for coming. Now, what about light-polluted areas? We understood that not everyone wants to drive to the dark sky Sierras to see the sky, so more than half of our star parties were close to or in towns in Northern California: Auburn, Meadow Vista, Colfax. With light-polluted skies, we showed the moon, planets, bright stars, double stars, and a few of the brightest star clusters. Because we wanted to show the moon, these were usually held when the moon was about first quarter. The moon was always a hit with our guest. When the weather warmed up, we booked star parties in the Sierras where the sky was dark. And there we showed 25 to 35 objects among all the telescopes, all of them in 90 minutes. We covered, from twilight until it got dark, the planets, bright stars, double stars, star clusters, galaxies, and nebula. We also pointed out bright artificial satellites when they came by. A big hit back in those days was the iridium satellites, which would flare. We would prepare for those and stand there in awe and watch them. For these dark sky parties, we chose evenings when the moon was not in the sky. Not all of our star parties were at night. Colfax, California holds their 4th of July on July 3rd with happenings in a small town, which is downtown. We were granted a couple of booths free of charge because we were not making money doing this. And we had to be there from 11 a.m. through 10 p.m. Now, in the daytime, we discussed astronomy as many families came by and asked about astronomy and the telescopes. We handed out star maps. We handed out light pollution information. And we handed out our star party schedule. We also took the time to explain how the telescopes worked, and we showed the sun, the moon if it was up, and even the planet Jupiter and the star Sirius in the daytime. As it got dark, the fireworks began, and we showed evening objects. We were very busy as the fireworks finished and the crowd of several thousands was dispersing. They all seemed to want to look at Saturn, Jupiter, the moon, or whatever was up. For this star party, some astronomers could be there for only a few hours, and we were happy for the time that they spent at the event. Our Mercury transits and partial solar eclipses were also held during the day and would last more than our customary 90 minutes. I know that many astronomy clubs who set up in the county fairs for daytime viewing. These star parties also recruit more members. But remember, You do not need to belong to an astronomy club to hold a star party. A couple nights in Colfax at their Winterfest in December, I brought my telescope to show both Jupiter and the moon. Good times. We tried one or two morning star parties before dawn to see a comet or planetary alignment, but got almost no guest at all. I would not recommend morning star parties. Next week, I'll discuss the A to Z of setting up public star parties. For these next two items, you might want to download from Podcast 11, Map 1. You'll find that on my website, donmachholtz.com. This week, we'll look at the Orion Nebula, also known by two Messier numbers, M42 and M43. M42 is the main portion, and M43 is a northern appendage to it. This nebula is a collection of gas and dust situated about 1,300 light years from us and 25 light years across. It is a location where stars are being formed, a star nursery, so to speak. To find it, first locate the constellation Orion. In our evening sky, it's fairly high in the south. Below the belt, which is made of three fairly bright stars, there are three more fainter stars headed southward. The middle star is the Orion Nebula. Our unaided eye challenge this week is to see the Orion Nebula with your unaided eye. You'll need a dark sky for it to stand out well. Note that it appears fuzzy and not star-like. With binoculars, the Orion Nebula appears larger and brighter. Depending upon your eyes, skies, and binoculars, you might notice some shape to it. You are unlikely to see any colors in it, but do get a good look at it. In the center of the nebula is a group of four stars known as a trapezium. See if you can pick up that group in binoculars. With the telescope, more detail can be seen in M42 and M43. Two stars in the four-star trapezium can be further split for a total of 6 stars in that tiny center. How far out can you trace the nebulosity, and can you see any color? Sometimes a green hue is seen. While your telescope's out, let's try a couple of bright double stars. The first is Rigel, and the second is Sirius. Rigel is in the constellation Orion and is marked on Podcast 11, Map 1. It is a multiple star system, but we'll be looking at only the two brightest stars. Rigel A, the brightest one, is 860 light years away from us, much larger than our sun and many times more luminous. It varies very slightly in brightness from plus 0.05 to plus 0.18 magnitude. Rigel B is magnitude 6.7, which is 400 times fainter than Rigel A, and it's 9.5 arcseconds away. They take 2,400 years to complete one orbit. Right now, the companion is south of the primary. The companion is south of the primary by 9.5 arcseconds. With a steady night and a medium to large telescope, this one should be visible under high magnification. Next, we move to the star Sirius, the brightest star in the sky. It's also marked on Map 1 of Podcast 11. Sirius is 8 light years away and shines at an incredible minus 1.46 magnitude. His companion is known as Sirius B, also known as the Pup. It's super dense white dwarf, magnitude 8.5 and about 10 arcseconds to the northeast of Sirius. With a 10 magnitude difference, the fainter star will be hard to pick up. If you don't see it, try again when the atmosphere is steadier. For the next few years, these stars will be at their greatest separation. Then they will be closing up again in their 50-year orbit. Before you pack up the telescope, take a look at the 3 comets we discussed last week. Maps for those 3 comets are found on my website, Podcast 10, Maps 2 and 3. Please note especially Comet Atlas C2019Y4. It has been brightening quite a bit over the last few weeks, and right now it's very close to 9th magnitude. It's probably our brightest comet in the sky. We will continue to watch this Comet Atlas over the next 3 months or so as it gets closer to the sun. It is possible that this comet will be visible in binoculars in a couple weeks, and to the unaided eye a few weeks after that. Now for fun with the marathon. Charles Messier was a comet hunter more than 200 years ago, who compiled a list of 110 galaxies, clusters, and nebula which he picked up while he was comet hunting. It is possible to locate and observe all 110 Messier objects in one night from mid-northern latitudes in late March. This year, many astronomy clubs will be holding their Messier marathons on the weekends of either March 21st or March 28th. Right now, with the moon out of the evening sky, get out there and practice locating those evening objects, especially the difficult ones, M77, 74, M33, and M110. With each passing night, they get lower in the sky at twilight, so learn them while they are still easily placed above your western horizon. To keep track of these objects and to make sure you don't miss any and to catch those in the west before they set, it helps to have an observing order. You can download one from my website. It's on Podcast 5, and it's called the Search Sequence. You might also want to download this map, Map 2, Podcast 11, MM9, and it shows the final 10 Messier objects that we'll be discussing this week. Podcast 5 through 11 trace a Messier object search sequence from the first object we find and observe during the Messier Marathon to the very last one. This is Podcast 11. And if you download all the maps from episode 5 through this one, you'll have the maps and the search sequence for the Messier Marathon later this month. When we left off last week, we had seen the 6th set of the Messier objects in the Messier Marathon and had covered 100 of the 110 objects. We are perhaps an hour before dawn, and these final objects have just risen or have yet to rise in the morning sky. All these objects but one is a globular cluster. Most globular clusters have a bright center, then taper off in brightness from the center to their edges. This is a good thing, as it makes it easier to find the cluster. The surface brightness of the center is brighter than the overall brightness of the whole cluster, making it more obvious in twilight and our low altitude conditions. M69 and M70 are two globular clusters south of the bowl of Sagittarius. Now there's other globular clusters in this region, including one that's midway between these two and slightly south. So be careful here and find the right ones. Our next target is M54. It's a very distant globular cluster, and therefore it's rather small. Under low magnification, it might even blend in with the stars. It's in the southern portion of the bowl of Sagittarius. Next we come to M55. This one can be difficult. It's not much brighter in the center because it is quite diffuse. It's rated at magnitude 6.1, but the light is spread out over a large area. Added to that is a low elevation, especially for more northerly locations, and twilight, and this can be a difficult object. When I did the Messier Marathon from my house in Colfax, California, a strand of trees a quarter mile away hid this object until it was several degrees above the true horizon. So sometimes I hit some of the other objects first and came back to this one last. Our next globular is M75, a small one that's not near any bright stars. However, this year, on the morning of March 29th, the planet Mars will be less than a degree north of M75, helping you to find the cluster. Mars will not be that close on March 28th or 30th, just on the 29th. The planet Saturn, moving much more slowly, will be about 2 degrees northeast of M75 for the whole week. So maybe use Saturn to find M75 this year. The bright globular star cluster M15 is next, and it's perhaps 20 degrees high in your eastern sky. It stands out well. Next we slide south 13 degrees for M2. This is more diffuse, and it's in an area where there may be some twilight. We are now down to our final 3 objects. The first 2 are visible for much of March. That is why you can do the Messier Marathon if the moon is right, from the second week of March to nearly the end of March and see 109 objects, missing just our final object, M30, but we're getting ahead of ourselves. M72, a globular cluster, is about as high in the sky as M2 was. It's not very condensed in appearance. It is diffuse, and it tends to blend in with the background. It's also a bit fainter than M2. You might have to look for this one very carefully before finding it. Our next object is M73. It consists of 4 stars in tight formation, and it's 1.3 degrees east of M72, but it does stand out well against a rather barren background. Finally, we get to M30. Now, this is the most missed object in the marathon. That is because at this time of year, it rises at about astronomical twilight, and the further north you are, the later it rises. Perhaps the earliest you could see it is about March 25th. From farther north, the dates advance to March 29th or 30th. There are a few guide stars in the area, but the one advantage we have is that M30 is bright and condensed and very close and east of a star of magnitude 8.6, and farther east of M30 by only 0.4 of a degree is a fairly bright star of magnitude 5.2. So there you have it, all 110 Messier objects. I bet you're tired. One sensation I get after every Messier marathon I've ever done is that I can often remember finding and seeing all 110 objects, or however many I have seen overnight. Usually it's not 110, with 109 being my most popular count. I know that it's been a span of perhaps 10 hours, but to remember those 100+ objects, the ease or difficulty of finding each, and the view of each is a feat for me. No matter how many Messier objects you saw, I hope this has been a good night for you. The Messier Marathon can be done any night of the year, so you don't have to wait until next March to do it again. You can also do mini marathons any evening of the year, doing only those visible in the first couple hours of the evening, then go home, go to sleep, or work on some other astronomical project. The combination is endless. You have been listening to Looking Up with Don, podcast episode 11 for March 18th, 2020. Once again, the related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com. 2 H's. God willing and pod willing, I'll be back next week for another episode of Looking Up with Don. We'll discuss what's going on in the night sky and more about organizing a public star party. Thank you for listening. See the sky this week. I'll see you next week.